Let's understand why we must balance chemical equations. There are two main reasons. First, the law of conservation. Atoms or moles are neither created nor destroyed in a chemical reaction. Atoms are only rearranged. Therefore, each atom must be accounted for during a chemical reaction. Take the example of methane reacting with oxygen to yield carbon dioxide and water. If you count each element on each side of the yield sign, you'll see that hydrogen and oxygen do not balance. We can never change the subscripts of the species. This would change the molecule. We can, however, insert coefficients in front of the species. For example, inserting a coefficient of 2 in front of water means that you multiply water by 2. Thus, you now have 2 water molecules in the balanced equation. In terms of counting moles, we can say that there are 4 moles of hydrogen present on the product side. Notice how the moles of oxygen have been changed as well. There are now 4 moles of oxygen on the product side. We'll need to balance the moles of oxygen next. We can balance the moles of oxygen on the reactant side by inserting a coefficient of 2 in front of the oxygen. All of the elements are now balanced. Notice there is no need to write the coefficient of 1. If no coefficient is present, a 1 is understood. This brings us to the second reason why we need to balance chemical equations. The coefficients in the balanced equation represents the mole ratios of each species in the reaction. This means that the coefficients tell us the exact ratio of moles of species reacting in the equation. If you can understand this concept, you can do any stoichiometry problem. We can read this equation as 1 mole of CH4 reacts with exactly 2 moles of O2 to yield exactly 1 mole of CO2 and exactly 2 moles of H2O. You use these ratios to convert one species to another in a stoichiometry problem. Let's recap. We balance equations to obey the law of conservation. Atoms or moles are neither created nor destroyed in a chemical reaction. Atoms are only rearranged. Thus, we must account for each moles of element. And second, the coefficients in the balanced equation are the stoichiometric ratios. Thus, you can use the ratios to do any stoichiometric conversion.